Hello everyone, welcome back to my channel Biostat Insight. Today we are going to discuss regression analysis and what type of regression analysis and how we interpret the regression analysis and what are the assumptions and examples of regression analysis. So here the correlation, what happened, you can able to check the relationship between two variables, but in regression analysis you can able to check the how much one variable correlated to another, or you can see the how much independent variable correlated to independent variable. You can assess the degree of correlation or like amount of relationship between two variables. So this is the descriptions that I have provided. What are the regression analysis? You can read it in the slide. Now, types of relationship. In the regression, there is a multiple types available like linear regressionships, polynomial regression, non-linear regression, multiple regression, logistic regression, and multivariate regression. And this, the most important is it like linear regression and then multiple linear regression, logistic and multivariate. So linear regressions is it the relationship between two variables in a straight line, that is known as linear relationship. Then multiple linear regression relationship is it like extension of linear relationship where you have two or more independent variable. Logistic regression, in the logistic regression when you have a dichotomous variable and you wanted to see the relationship between dependent variable. Multivariate regression where involve multiple dependent variable predicted simultaneously. Now we are going to check what is the simple linear regression. So in the regression model it is written as the equation, your model fitting, it is y equal to beta 0 plus beta 1 x1 plus error term. So where y is your dependent variable, x is your independent variable, beta 0 is your intercept, that is value of y when x is 0. If we have put it x here is equals to 0, so the whole term is 0 and error also normally distributed towards 0, mean and standard deviation 1, and then y equal to 0. Beta, beta 1, beta 1 is the slope of line. So change in y for a 1 unit change in x. Error term follow normal distributions, and multiple regression where we have multiple independent variables that influence the results of dependent variable, that is why. So in this graph you can see this is the line, straight line, that is the slope of the variables, slope of the data, and you can see these are the where points are mostly likely towards in the slopes. Now key concept means these variables or these factors that help you to interpret the regression analysis. So the R square is that help you to measure how well the model fit in the data, or you can say proportion of variance in dependent variable predicted from independent variables. If it is closely related to 1 or closely 10 to 1, that is known as the best fit or a better fit. So R square and adjusted R square, it is in the adjusted R square, it is similar R square, but this is adjusted for the number of predictors, the number of predictors that help you predict the value of dependent variable. So if any adjustment needed, that will cover up by the adjusted R square. P value is a statistical significance of each coefficient. A small p value suggested a significant relationship. Okay, so residual is a difference between predicted and observed values, and it is the assumptions. Help you to check the assumption of the regression. So what is the assumption? First one is the variable should be linearly related towards each others. Homoscedasticity, the variance in residual is constant across all the independent variable. Independence, all the observations are independent to each other. There is no correlation or correlative between each others. Normality, residual are normally distributed. Applications, for example, predictive modeling. If we, for example, we wanted to estimate the house prices based on the land area and the size and the locations, so it will help you to decide the house pricing. Risk assessment, if you wanted to see the risk assessment, if like for example if you are applying for the loan, then bank will based on your credit score, they will assess what how much amount the loan are you eligible. So it is like a risk assessment. Example, trend analysis, for example if you wanted to see the trend by over the time, like for the first quarter what your sale estimate it is, that is called as trend. And health score, what like you wanted to study that what factor impacted your daily lifestyles. Then interpreting regression output. So in the interpretation, first one you have to check r square, then adjusted r square, then significance level, then the coefficient and confidence interval. The coefficient is beta 1 and beta 2, that indicates that change in dependent variable for a one unit change in the respective independent variable. Significance level assess whether coefficient of a statistically significant from 0 using p-value, and a small p-value indicating the better significance level. Confidence interval provide the range of true values of the coefficient expected to fall. Usually it is 95%. Limitation, there is a limitation, there is no multicollinearity present in the data. Extrapolation risk also there, are overfitting and assumption of violations. So you can read it in the slide what are the different type of limitations are present in the regression. Okay, that's all from my end. We will come back again with the topic that much be interesting. For the time being, if you have any questions and doubt, please write it in the comment. I will happy to respond it. And thank you everyone for watching this. Please like, subscribe and share. Bye bye.